Alright, so today we're going to be taking a look at how to factor quadratics that don't exactly have a leading coefficient of 1. So it's this one, 2x squared plus 3x minus 5. So basically the process really isn't all that much different than factoring quadratics with a leading coefficient of 1, but it's still a little different. So basically, instead of finding two numbers that multiply out to our constant term only, we need to find two numbers that multiply out to the product of our leading coefficient and our constant term, and then obviously that also add up to our middle term. So we need to find two numbers that multiply out to 2 times -5, or two numbers that multiply out to -10 that also add up to +3. So I'm just go through that real quick, and let's see here. -10, 1, that doesn't work. -5, 2, that doesn't work. For 5 and -2, that works, because 5 times -2 is -10, right? And 5 plus -2 has us +3, right? So there we go. We got our two special numbers right here, 5 and -2. But instead of going straight to factored form like we did before, we're going to do something different. We're going to break up our middle term, plus 3x, like this. So obviously I got my 2x squared, right? I'm going to break up my middle term and rewrite it like this. 5x minus 2x minus 5. Right? And the reason I'm doing this, because I want to do something, I'm thinking ahead, right? I want to take these two groups out of my four terms. I want to take each pair of two terms, factor it completely, and then find a common factor in each of these pairs that I can then take out to do the ultimate factorization. So that might not make much sense right now, but I'll show you. So first things first, we're gonna factor out this pair as much as we can. So let's see here. I think the most I can do is just take out our next, right? So let's take out our next, and I'll get 2x plus 5, right? And then I'll factor this term, not this term, this pair as much as I can. And I want to make sure that I can get a common factor in both these pairs, right? That I can take out. So let's see here. I think I'm going to take out a -1 actually. So I'll take out a -1 and rewrite it as 2x plus 5. Well, not rewrite, but you know what I mean, right? So I took out a -1, so I got these common factors, right? So I got the common factor 2x plus 5 in both my pairs that I can take out, right? So now that I got my common factor, I can just rewrite the entire thing like this. 2x plus 5 times x minus 1, right? I basically undistributed the 2x plus 5, if you want to think about it like that, because if I can redistribute right here 2x plus 5 to the x and to the -1 and get the same thing up here, right? So that's basically it, really. That's how you factor quadratics, trinomials with a leading coefficient that's not really equal to 1. And you notice that I wrote 5x minus 2x right here. That's how I broke up my middle term, but it really wouldn't matter if I wrote it as minus 2x plus 5x. It doesn't matter how I break up the middle term. So see, I think I'll show it to you right here if I broke it up the other way. So I got me 2x squared minus 2x plus 5x minus 5, right? So I broke it up the different way. Instead of writing 5x minus 2x, I wrote minus 2x plus 5x, right? So again, I got my two pairs right here. I'm just factor this first pair. I can take out 2x this time. So 2x times x minus 1. And my second pair, I could take out a 5. So plus 5 times x minus 1, right? To get my common factor of x minus 1. Take x minus 1 out, undistribute it, if you want to call it that. Now I'll get, again, x minus 1 times 2x plus 5. Alright, so it really doesn't matter how you break up the middle term. You're going to get the same answer, same factorization either way. So yeah, this is really it. That's how you factor quadratics whose leading coefficient isn't exactly 1. It's not too different from our old factoring that we did where the leading coefficient was 1. Just small change. You just need to find two numbers that multiply it to the product of our first and last term. Alright, but besides that, it's not too different, except for the fact you just break up the middle term and then do more factorizations. But overall, not too bad. And I think in a future video, well, you already know how to solve quadratics by factored form. If you haven't solved quadratics in factored form when they're set equal to 0, if you haven't seen that, then you can see my other video on that. Really the same process. And yeah, that's it for today.